Welcome to the facility for Advanced Imaging and Microscopy at Virginia Tech. Here we house confocal, extended, and super resolution light microscopy instruments, so investigators have the resources to address their research questions.
People who could use microscopy include people who want to visualize distribution of something within their sample, whether it's cell populations in a tissue section or maybe a protein distribution within a cell. That's where microscopy can come in. Because it's a visual technique, it's imaging, so you need to have a question that needs visualization. Things like, where is this in my sample? Or what does my sample look like after this treatment? This is the Nikon AXR. It's their point scanning confocal. A point scanner will direct to lasers with mirrors, point by point, line by line, or raster scan them. Point scanning confocal is a workhorse confocal. That's what a lot of people tend to think about when they think about light microscopy. And it's really useful, especially because the pinhole in the light path is movable. So it will change or adjust based on your imaging. That lends to higher resolution and better what people call confocality. This confocal has 8 excitation laser lines. It has 2 tunable detectors, meaning that you can actually change the emission wavelengths that you're looking at. And it also is equipped with technically a near infrared or NIR specialized detector as well. Because people tend to come to point scanning confocals for higher confocality, we also put extra resolution modules on this. So this also is equipped with a separate type of detector called an array detector. Nikon calls it N-Spark, and so you get slightly better resolution. And it also has an barrier Steadicon module, which is a super resolution technique. So since it's a true super resolution technique, we're getting down to, 30 to 40 nanometers laterally. So that has really high resolution for a lot of different applications, a lot of people who are looking at very small sub-organellar things. People will generally use like a point scanning confocal for fixed samples, like fixed cells, fixed tissue. You can do live work on it as well. So this is the Nikon Sora spinning disc confocal. So this spinning disc confocal is equipped with 7 laser lines, 2 highly quantum efficient cameras for dual imaging if you need. The spinning disc is typically used for experiments where you have live samples, you need to capture high dynamics, or you don't need as much of the confocality that a point scanner can offer. Even though they're both lasers, the spinning disc has a disc that actually spins and that's filled with pinholes, and that's where you get your confocal resolution. This is much faster, very suitable for gentle imaging. They have a second pinhole set in here called the Sora. Theoretically, confocal has a resolution limit between 200 and 250 nanometers. So the Sora disc uses micro lenses for that optical reassignment to bring the resolution down to about 120 to 140 nanometers. It's also equipped with a water bath incubator, so you can do both heating and cooling for your samples. And it also has a photostimulation unit for people who need to do photoactivation, photoconversion, and things like that. So here in Fralin Hall, we have the Zeiss LSM880, which is another point scanning confocal microscope. It has 7 laser lines, 2 tunable PMTs, and it's also equipped with the first generation of ARIScan, which is Zeiss's extended resolution array detector. There's also an offline analysis and processing station that has NIS elements analysis and also a batch denoise and batch deconvolution. One example of what we can do is try to figure out what sort of resolution your images need. We talked a lot about why resolution is important and why super resolution is not always the answer. For example, this is a comparison of a confocal, traditional point scanning confocal versus the N-Spark array detector versus the super resolution STED of inner nuclear membrane protein distribution. So we decided that the STED was actually the best way to go for this, and that is just related to the type of resolution that was needed for this image. So if you want to come and use the facility, I generally do free consultations so people can come with samples and we can make sure that the imaging is what they need and it's going to address their research question. I do assisted sessions if people know that they don't need a lot of imaging. I also do training sessions for people who will need to do consistent imaging. And I'm always around to answer questions just because it's a new instrument for a lot of people. And so it would be good to not break it.